In this lesson, you will learn about FortiGate administration basics and the components within FortiGate that can be enabled to extend functionality. This lesson also includes details about how and where FortiGate fits into your existing network architecture. In this lesson, you will explore the topics shown on this slide. After completing this section, you should be able to achieve the objective shown on this slide. By demonstrating competence in identifying the platform design features of FortiGate, features of FortiGate in virtualized networks and the cloud, as well as the FortiGate security processing units, you will be able to describe the fundamental components of FortiGate and explain the types of tasks that FortiGate can do. In the past, the common way of protecting a network was securing the perimeter and installing a firewall at the entry point. Network administrators used to trust everything and everyone inside the perimeter. Now, malware can easily bypass any entry point firewall and get inside the network. This could happen through an infected USB stick or an employee's compromised personal device being connected to the corporate network. Additionally, because attacks can come from inside the network, network administrators can no longer inherently trust internal users and devices. What's more, today's networks are highly complex environments whose borders are constantly changing. Networks run vertically from the LAN to the internet and horizontally from the physical network to a private virtual network and to the cloud. A mobile and diverse workforce, employees, partners, and customers accessing network resources, public and private clouds, the Internet of Things, IoT, and bring your own device programs all conspire to increase the number of attack vectors against your network. In response to this highly complex environment, firewalls have become robust multifunctional devices that counter an array of threats to your network. Thus, FortiGate can act in different modes or roles to address different requirements. For example, FortiGate can be deployed as a data center firewall whose function is to monitor inbound requests to servers and to protect them without increasing latency for the requester. Or FortiGate can be deployed as an internal segmentation firewall as a means to contain a network breach. FortiGate can also function as DNS and DHCP servers and be configured to provide web filter, antivirus, and IPS services. In the architecture diagram shown on this slide, you can see how FortiGate platforms add strength without compromising flexibility. Like separate dedicated security devices, FortiGate is still internally modular. Plus, devices add duplication. Sometimes dedication doesn't mean efficiency. If it's overloaded, can one device borrow free RAM from 9 others? Do you want to configure policies, logging and routing on 10 separate devices? Does 10 times the duplication bring you 10 times the benefit, or is it a hassle? For smaller to mid-sized businesses or enterprise branch offices, Unified Threat Management, UTM, is often a superior solution compared to separate dedicated appliances. FortiGate hardware isn't just off the shelf, it's carrier grade. Most FortiGate models have one or more specialized circuits, called ASICs, that are engineered by Fortinet. For example, a CP or NP chip handles cryptography and packet forwarding more efficiently. Compared to a single-purpose device with only a CPU, FortiGate can have dramatically better performance. This is especially critical for data centers and carriers where throughput is business critical. The exception? Virtualization platforms, VMware, Citrix Xen, Microsoft, or Oracle VirtualBox, have general-purpose vCPUs. But virtualization might be worthwhile because of other benefits, such as distributed computing and cloud-based security. FortiGate is flexible. If all you need is fast firewalling and antivirus, FortiGate won't require you to waste CPU, RAM, and electricity on other features. In each firewall policy, UTM and next-generation firewall modules can be enabled or disabled. Also, you won't pay more to add VPN seat licenses later. FortiGate cooperates. A preference for open standards instead of proprietary protocols means less vendor lock-in and more choice for system integrators. And as your network grows, FortiGate can leverage other Fortinet products such as FortiSandbox and FortiWeb to distribute processing for deeper security and optimal performance. A total security fabric approach. FortiGate virtual machines, VMs, have the same features as physical FortiGates, except for hardware acceleration. Why? First, the hardware abstraction layer software for hypervisors is made by VMware, Xen, and other hypervisor manufacturers, not by Fortinet. Those other manufacturers don't make Fortinet's proprietary FortiASIC chips. But there is another reason too. The purpose of generic virtual CPUs and other virtual chips for hypervisors is to abstract the hardware details. That way, all VM guest OSs can run on a common platform, no matter the different hardware on which the hypervisors are installed. Unlike vCPUs or vGPUs that use generic, non-optimal RAM and vCPUs for abstraction, FORTA ASIC chips are specialized, optimized circuits. Therefore, a virtualized ASIC chip would not have the same performance benefits as a physical ASIC chip. If performance or equivalent hardware is less, you may wonder, why would anyone use a FortiGate VM? In large-scale networks that change rapidly and may have many tenants, equivalent processing power and distribution may be achievable using larger amounts of cheaper, general-purpose hardware. Also, trading some performance for other benefits may be worth it. You can benefit from faster network and appliance deployment and teardown. FortiGate VMX and the FortiGate connector for Cisco ACI are specialized versions of FortiOS and an API that allows you to orchestrate rapid network changes through standards such as OpenStack for software-defined networking, SDN. FortiGate VM is deployed as a guest VM on the hypervisor. FortiGate VMX is deployed inside a hypervisor's virtual network between guest VMs. FortiGate connector for Cisco ACI allows ACI to deploy physical or virtual FortiGate VMs for north-south traffic. All Fortinet hardware acceleration hardware has been renamed Security Processing Units, SPUs. This includes NPX and CPX processors. Most FortiGate models have specialized acceleration hardware called SPUs that can offload resource-intensive processing from main processing CPU resources. Most FortiGate devices include specialized content processors, CPs, that accelerate a wide range of important security processes such as virus scanning, attack detection, encryption, and decryption. Only selected entry-level FortiGate models do not include a CP processor. Many FortiGate models also contain security processors, SPs, that accelerate processing for specific security features such as IPS and network processors, NPs, that offload processing of high-volume network traffic. SPU and NTurbo data is now visible in a number of places on the GUI. For example, the Active Sessions column pop-up in the Firewall Policy list and the Sessions Dashboard widget. Per-session accounting is a logging feature that allows the FortiGate to report the correct bytes per packet numbers per session for sessions offloaded to an NP6 or NP6 Lite processor. The following example shows the Sessions Dashboard widget tracking SPU and NTurbo sessions. Current session shows the total number of sessions. SPU shows the percentage of these sessions that are SPU sessions, and NTurbo shows the percentage that are NTurbo sessions. NTurbo offloads firewall sessions that include flow-based security profiles to NP4 or NP6 network processors. Without NTurbo, or with NTurbo disabled, all firewall sessions that include flow-based security profiles are processed by the FortiGate CPU. Fortinet's content processor, CP9, works outside of the direct flow of traffic, providing high-speed cryptography and content inspection services. This frees businesses to deploy advanced security whenever it is needed without impacting network functionality. CP8 and CP9 provide a fast path for traffic inspected by IPS, including sessions with flow-based inspection. CP processors also accelerate intensive proxy-based tasks, encryption and decryption, SSL, antivirus. FortiGate security processing, SP modules, such as the SP3, but also including the XLP, XG2, XE2, FE8, and CE4, work at both the interface and system level to increase overall system performance by accelerating specialized security processing. You can configure the SP to favor IPS over firewall processing in hostile, high-traffic environments. FortiASIC network processors work at the interface level to accelerate traffic by offloading traffic from the main CPU. Current models contain NP4, NP4 Lite, NP6, and NP6 Lite network processors. Fortinet integrates content and network processors along with RISC-based CPU into a single processor known as SOC 3 for entry-level FortiGate security appliances used for distributed enterprises. This simplifies appliance design and enables breakthrough performance without compromising on security. Good job! You now understand some of the high-level features of FortiGate. Now you will learn how to perform the initial setup of FortiGate and learn about why you might decide to use one configuration over another. After completing this section, you should be able to achieve the objective shown on this slide. By demonstrating competence in setting up FortiGate, you will be able to use the device effectively in your own network. What about the network architecture? Where does FortiGate fit in? When you deploy FortiGate, you can choose between two operating modes, NAT mode or transparent mode. In NAT mode, FortiGate routes packets based on layer 3 like a router. Each of its logical network interfaces has an IP address, and FortiGate determines the outgoing or egress interface based on the destination IP address and entries in its routing tables. In transparent mode, FortiGate forwards packets at layer 2, like a switch. Its interfaces have no IP addresses, and FortiGate determines the outgoing or egress interface based on the destination MAC address. The device in transparent mode has an IP address used for management traffic. Interfaces can be exceptions to the router versus switch operation mode on an individual basis. Network address translation, NAT mode, is the default operation mode. What are the other factory default settings? After you've removed FortiGate from its box, what do you do next? Now you'll take a look at how you set up FortiGate. Attach your computer's network cable to port 1 or the internal switch ports, depending on your model. In most entry models, there is a DHCP server on that interface, so if your computer's network settings have DHCP enabled, your computer should automatically get an IP and you can begin setup. To access the GUI on FortiGate or FortiWi-Fi, open a web browser and go to http://192.168.1.99. The default login information is public knowledge. Never leave the default password blank. Your network is only as secure as your FortiGate's admin account. Before you connect FortiGate to your network, you should set a complex password. All FortiGate models have a console port and/or USB management port. The port provides CLI access without a network. The CLI can be accessed by the CLI console widget in the GUI or from a terminal emulator such as PuTTY or TerraTerm. Some FortiGate services connect to other servers such as FortiGuard in order to work. FortiGuard subscription services provide FortiGate with up-to-date threat intelligence. FortiGate uses FortiGuard by periodically requesting packages that contain a new engine and signatures, querying the FDN on an individual URL or hostname. By default, FortiGuard server location is set to anywhere FortiGate will select a server based on server load from any part of the world. However, you have an option to change the FortiGuard server location to USA. In this case, FortiGate will select a USA-based FortiGuard server. Queries are real-time. That is, FortiGate asks the FDN every time it scans for spam or filtered websites. FortiGate queries instead of downloading the database because of the size and frequency of changes that occur to the database. Also, you can select queries to use UDP or HTTPS for transport. The protocols are not designed for fault tolerance, but for speed. So queries require that your FortiGate has a reliable internet connection. Packages like antivirus and IPS are smaller and don't change as frequently, so they are downloaded, in many cases, only once a day. They are downloaded using TCP for reliable transport. After the database is downloaded, their associated FortiGate features continue to function even if FortiGate does not have reliable internet connectivity. However, you should still try to avoid interruptions during downloads. If your FortiGate must try repeatedly to download updates, it can't detect new threats during that time. Good job! You now understand how to perform the initial setup of FortiGate and why you might decide to use one configuration over another. Now you will learn about basic administration. After completing this lesson, you should be able to achieve the objective shown on this slide. By demonstrating competence in basic administration, you will be able to better manage administrative users and implement stronger security practices around administrative access. Most features are available on both the GUI and CLI, but there are a few exceptions. Reports cannot be viewed on the CLI. Also, advanced settings and diagnostic commands for super users are usually not available on the GUI. As you become more familiar with FortiGate, and especially if you want to script its configuration, you may want to use the CLI in addition to the GUI. You can access the CLI through either the JavaScript widget in the GUI named CLI Console, or through a terminal emulator such as TerraTerm or PuTTY. Your terminal emulator can connect to the network, SSH or Telnet, or the local console port. SNMP and some other administrative protocols are also supported, but they are read-only. They can't be used for basic setup. This slide shows some basic CLI commands that you can use to list commands under a command set, check the system status, and list attributes and their values for an interface. Whichever method you use, start by logging in as admin. Begin by creating separate accounts for other administrators. For security and tracking purposes, it is a best practice for each administrator to have their own account. In the Create New drop-down list, you can select either Administrator or REST API Admin. Typically, you will select Administrator and then assign an administrator profile, which specifies that user's administrative permissions. You could select REST API Admin to add an administrative user who would use a custom application to access FortiGate with a REST API. The application would allow you to log into FortiGate and perform any task that your assigned administrator profile permits. Other options not shown here include, instead of creating accounts on FortiGate itself, you could configure FortiGate to query a remote authentication server. In place of passwords, your administrators could authenticate using digital certificates that are issued by your internal certification authority server. If you do use passwords, ensure that they are strong and complex. For example, you could use multiple interleaved words with varying capitalization and randomly insert numbers and punctuation. Do not use short passwords or passwords that contain names, dates, or words that exist in any dictionary. These are susceptible to brute force attack. To audit the strength of your passwords, use tools such as L0PHTCrack or John the Ripper. Risk of a brute force attack is increased if you connect the management port to the internet. In order to restrict access to specific features, you can assign permissions. When assigning permissions to an administrator profile, you can specify read and write, read-only, or none to each area. By default, there is a special profile named SuperAdmin, which is used by the account named Admin. It cannot be changed. It provides full access to everything, making the admin account similar to a root superuser account. The Prof Admin is another default profile. It also provides full access, but unlike SuperAdmin, it only applies to its virtual domain, not the global settings of FortiGate. Also, its permissions can be changed. You aren't required to use a default profile. You could, for example, create a profile named Auditor Access with read-only permissions. Restricting a person's permissions to those necessary for his or her job is a best practice. Because even if that account is compromised, the compromise to your FortiGate or network is not total. To do this, create administrator profiles, then select the appropriate profile when configuring an account. The Override Idle Timeout feature allows the admin timeout value under Config System ACC Profile to be overridden per access profile. Administrator profiles can be configured to increase inactivity timeout and facilitate use of the GUI for central monitoring. Note that this can be achieved on a per-profile basis to prevent the option from being unintentionally set globally. What are the effects of administrator profiles? It's actually more than just read or write access. Depending on the type of administrator profile that you assign, an administrator may not be able to access the entire FortiGate. For example, you could configure an account that can view only log messages. Administrators may not be able to access global settings outside their assigned virtual domain either. Virtual domains, VDOMs, are a way of subdividing the resources and configurations on a single FortiGate. Administrators with a smaller scope of permissions cannot create or even view accounts with more permissions. So for example, an administrator using the Prof Admin or a custom profile cannot see or reset the password of accounts that use the Super Admin profile. To further secure access to your network security, use two-factor authentication. Two-factor authentication means that instead of using one method to verify your identity, typically a password or digital certificate, your identity is verified by two methods. In the example shown on this slide, two-factor authentication includes a password plus an RSA randomly generated number from a FortiToken that is synchronized with FortiGate. What happens if you forget the password for your admin account or a malicious employee changes it? This recovery method is available on all FortiGate appliance devices and even some non-FortiGate devices like FortiMail. There is no maintainer procedure in VM. Administrators must revert to snapshot or reprovision the VM and restore configuration. It's a temporary account only available through the local console port and only after a hard reboot, disrupting power by unplugging or turning off the power, then restoring it. FortiGate must be physically shut off, then turned back on, not simply rebooted through the CLI. The maintainer login will only be available for login for about 60 seconds after the restart completes, or less time on older models. If you cannot ensure physical security or have compliance requirements, you can disable the maintainer account. Use caution. If you disable maintainer and then lose your admin password, you cannot recover access to your FortiGate. In order to regain access in this scenario, you will need to reload the device. This will reset to factory default. Another way to secure your FortiGate is to define the hosts or subnets that are trusted sources from which to log in. In this example, we have configured 10.0.1.10 as the only trusted IP for admin1, from which admin1 login. If admin1 attempts to log in from a machine with any other IP, they will receive an authentication failure message. Note that if trusted hosts are configured on all administrators and an administrator is trying to log in from an IP address that is not set on any of the trusted hosts for any administrators, then the administrator will not get the login page, but rather will receive the message, "Unable to contact server." If you leave any IPv4 address as 0.0.0.0/0, it means that connections from any source IP will be allowed. By default, 0.0.0.0/0 is the configuration for administrator, although you may want to change this. Notice that each account can define its management host or subnet differently. This is especially useful if you are setting up VDOMs on your FortiGate, where the VDOM's administrators may not even belong to the same organization. Be aware of any NAT that occurs between the desired device and FortiGate. You can easily prevent an administrator from logging in from the desired IP address if it is later NATed to another address before reaching FortiGate, thus defeating the purpose of the trusted hosts. You may also want to customize the administrative protocol's port numbers. You can choose whether to allow concurrent sessions. This can be used to prevent accidentally overwriting settings if you usually keep multiple browser tabs open or accidentally leave a CLI session open without saving the settings, then begin a GUI session and accidentally edit the same settings differently. For better security, use only secure protocols and enforce password complexity and changes. The idle timeout settings specifies the number of minutes before an inactive administrator session times out. Default is 5 minutes. A shorter idle timeout is more secure, but increasing the timer can help reduce the chance of administrators being logged out while testing changes. You can override the idle timeout setting per administrator profile using the Override Idle Timeout. You can configure an administrator profile to increase inactivity timeout and facilitate use of the GUI for central monitoring. The Override Idle Timeout setting allows the admin timeout value under Config System ACC profile to be overwritten per access profile. Note that this can be achieved on a per-profile basis to avoid the option from being unintentionally set globally. You've defined the management subnet, that is, the trusted hosts, for each administrator account. How do you enable or disable management protocols? This is specific to each interface. For example, if your administrators connect to FortiGate from only port 3, then you should disable administrative access on all other ports. This prevents brute force attempts and also insecure access. Your management protocols are HTTPS, HTTP, ping, SSH. By default, the telnet option is not visible on the GUI. Consider the location of the interface on your network. Enabling ping on an internal interface is useful for troubleshooting. However, if it's an external interface, in other words exposed to the internet, then the ping protocol could expose FortiGate to a DOS attack. Protocols that do not encrypt data flow, such as HTTP and Telnet, should be disabled. IPv4 and IPv6 protocols are separate. It's possible to have both IPv4 and IPv6 addresses on an interface, but only respond to pings on IPv6. Notice that some protocols like FortiTelemetry are not for administrative access, but like GUI and CLI access, they are protocols where the packets will have FortiGate as a destination IP, and not use FortiGate only as the next hop or bridge. The FortiTelemetry protocol is used specifically for managing FortiClients and the security fabric. FMG Access Protocol is used specifically for communicating with FortiManager when that server is managing multiple FortiGate devices. The cap2vid1 protocol is used for FortiAP, FortiSwitch, and FortiExtender when they are managed by FortiGate. Radius Accounting Protocol is used when FortiGate needs to listen for and process radius accounting packets for single sign-on authentication. FTM, or FortiToken Mobile Push, supports second-factor authentication requests from a FortiToken mobile app. The push service is provided by Apple, APNS, and Google, GCM, for iPhone and Android smartphones respectively. In addition, FortiOS supports FTM Push when FortiAuthenticator is the authentication server. When you assign the interface roles LAN or WAN to the appropriate interfaces, your FortiGate uses Link Layer Discovery Protocol, LLDP, to detect if there is an upstream FortiGate in your network. If an upstream FortiGate is discovered, you're prompted to configure the FortiGate to join the security fabric. FortiGate has hundreds of features. If you don't use all of them, hiding features that you don't use makes it easier to focus on your work. Hiding a feature on the GUI does not disable it. It is still functional and still can be configured using the CLI. Some advanced or less commonly used features, such as IPv6, are hidden by default. To show hidden features, click System, Feature Visibility. When FortiGate is operating in NAT mode, every interface that handles traffic must have an IP address. When in NAT mode, the IP address can be used by FortiGate to source the traffic if it needs to start or reply to a session, and can be used as a destination address for devices trying to contact FortiGate or route traffic through it. There are multiple ways to get an IP address: manually, automatically using either DHCP or PPPoE. There is an exception to the IP address requirement: the one-arm sniffer interface type. This interface is not assigned an address. When one-arm sniffer is selected as the addressing mode, the interface is not in line with the traffic flow. Rather, it is receiving a copy of the traffic from a mirrored port on a switch. The interface operates in promiscuous mode, scanning traffic that it sees, but is unable to make changes as the original packet has already been processed by the switch. As a result, one-arm sniffer mode is mostly used in proof of concept, POC, or in environments where corporate requirements state that traffic must not be changed, only logged. How many times have you seen network issues caused by a DHCP server, not client, enabled on the WAN interface? You can configure the interface's role. The roles shown in the GUI are the usual interface settings for that part of a topology. Settings that do not apply to the current role are hidden on the GUI. All settings are always available on the CLI regardless of the role. This prevents accidental misconfiguration. For example, when the role is configured as WAN, there is no DHCP server and device detection configuration available. Device detection is usually used to detect devices internally on your LAN. If there is an unusual case and you need to use an option that's hidden by the current role, you can always switch the role to undefined. This displays all options. To help you remember the use of each interface, you can give them aliases. For example, you could call port 3 internal network. This can help you make your list of policies easier to comprehend. Before you integrate FortiGate into your network, you should configure a default gateway. If FortiGate gets its IP address through a dynamic method such as DHCP or PPPoE, then it should also retrieve the default gateway. Otherwise, you must configure a static route. Without this, FortiGate will not be able to respond to packets outside the subnets directly attached to its own interfaces. It probably also will not be able to connect to FortiGuard for updates and may not properly route traffic. Routing details are covered in another lesson. For now, you should make sure that FortiGate has a route that matches all packets. Destination is 0.0.0.0/0, known as a default route, and forwards them through the network interface that is connected to the Internet to the IP address of the next router. Routing completes the basic network settings that are required before you can configure firewall policies. Link aggregation logically binds multiple physical interfaces into a single channel. Link aggregation increases bandwidth and provides redundancy between two network devices. Good job! You now have the knowledge to carry out some basic administrative tasks. Now you'll learn about built-in servers. After completing this section, you should be able to achieve the objective shown on this slide. By demonstrating competence in implementing the DHCP and DNS built-in servers, you will now know how to provide these services through FortiGate. Wireless clients are not the only ones that can use FortiGate as their DHCP server. For an interface, such as port 3, select the manual option, enter a static IP, and then enable the DHCP server option. Options for the built-in DHCP server will appear, including provisioning features such as DHCP options and IP address assignment rules. You can also block specific MAC addresses from receiving an IP address. Note that in the screenshot on the middle of the slide, in the IP address assignment rule section, you can create IP address assignment rules. For the built-in DHCP server, you can reserve specific IP addresses for devices with specific MAC addresses. The action selected for unknown MAC addresses defines what FortiGate's DHCP server will do when it gets a request from a MAC address not explicitly listed. By default, FortiGate implicitly rules action type is assign IP. However, you can change the default action type to assign IP or block. Assign IP permits the DHCP server to assign from its pool of addresses to the identified MAC address. A device receiving an IP address will always receive the same address, provided that its lease is not expired. Block. The computer with the identified MAC address and the block option will not receive an IP address. Reserve IP. Allows you to bind a specific IP to a MAC address. You can configure FortiGate to act as your local DNS server. You can enable and configure DNS separately on each interface. A local DNS server can improve performance for your FortiMail or other devices that use DNS queries frequently. If your FortiGate offers DHCP to your local network, DHCP can be used to configure those hosts to use FortiGate as both a gateway and DNS server. FortiGate can answer DNS queries in one of three ways. Forward. Relays all queries to a separate DNS server that you have configured in Network DNS. That is, it acts as a DNS relay instead of a DNS server. Non-recursive. Replies to queries for items in FortiGate's DNS databases and does not forward unresolvable queries. Recursive. Replies to queries for items in FortiGate's DNS databases and forwards all other queries to a separate DNS server for resolution. You can configure all modes on the GUI or CLI. If you choose recursive, FortiGate queries its own database before forwarding unresolved requests to the external DNS servers. If you choose the DNS forwarding option, you can control DNS queries within your own network without having to enter any DNS names in FortiGate's DNS server. If you choose to have your DNS server resolve queries, or you choose a split DNS, you must set up a DNS database on your FortiGate. This defines the host names that FortiGate will resolve queries for. Note that FortiGate currently supports only the DNS record types listed on this slide. Good job! You now know how to enable DHCP and DNS services in FortiGate and have some understanding of configuration possibilities. Now you will learn about fundamental maintenance. After completing this section, you should be able to achieve the objective shown on this slide. By demonstrating competence in implementing basic maintenance of FortiGate, you will be able to perform the vital activities of backup and restore, and upgrade or downgrade firmware, and ensure that FortiGate remains reliably in service throughout its lifecycle. Now that FortiGate has basic network settings and administrative accounts, you will learn how to back up the configuration. In addition to selecting the destination of the backup file, you can choose to encrypt or not to encrypt the backup file. Even if you choose not to encrypt the file, which is the default, the passwords stored in the file are hashed and therefore obfuscated. The passwords that are stored in the configuration file would include passwords for the administrative user and local users, and pre-shared keys for your IPsec VPNs. It may also include passwords for the FSSO and LDAP servers. The other option is to encrypt the configuration file with a password. Besides securing the privacy of your configuration, it also has some effects you may not expect. After encryption, the configuration file cannot be decrypted without the password and a FortiGate of the same model and firmware. This means that if you send an encrypted configuration file to Fortinet technical support, even if you give them the password, they cannot load your configuration until they get access to the same model of FortiGate. This can cause unnecessary delays when resolving your ticket. If you enable virtual domains, VDOMs, subdividing the resources and configuration of your FortiGate, each VDOM administrator can back up and restore their own configurations. You don't have to back up the entire FortiGate configuration, however, it is still recommended. Backups are needed to help speed up the return to production in the event of an unforeseen disaster that damages FortiGate. Having to recreate hundreds of policies and objects from scratch takes a significant amount of time, while loading a configuration file on a new device takes much less. Restoring a configuration file is very similar to backing one up and restarts the FortiGate. If you open the configuration file in a text editor, you'll see that both encrypted and unencrypted configuration files contain a clear text header that contains some basic information about the device. The example on this slide shows what information is included. To restore an encrypted configuration, you must upload it to a FortiGate of the same model and firmware, then provide the password. To restore an unencrypted configuration file, you are required to match only the FortiGate model. If the firmware is different, FortiGate will attempt to upgrade the configuration. This is similar to how it uses upgrade scripts on the existing configuration when upgrading firmware. However, it is still recommended to match the firmware on FortiGate to the firmware listed in the configuration file. Usually, the configuration file only contains non-default settings, plus few default yet crucial settings. This minimizes the size of the backup, which could otherwise be several megabytes in size. You can view the current firmware version in multiple places on the FortiGate GUI. When you first log into FortiGate, the landing page is the dashboard. You will see the firmware version in the System widget. This information is also found at System Firmware. And of course, you can retrieve the information on the CLI using the command get system status. If a new version of the firmware is available, you will be notified on the dashboard and on the firmware page. Remember to read the release notes to make sure that you understand the supported upgrade path. The release notes also provide pertinent information that may affect the upgrade. Upgrading the firmware on FortiGate is simple. Click System, Firmware, and then browse to the firmware file that you have downloaded from support.fortinet.com or choose to upgrade online. If you want to make a clean install by overwriting both the existing firmware and its current configuration, you can do this using the local console CLI within the bootloader menu while FortiGate is rebooting. However, this is not the usual method. You can also downgrade the firmware. Because settings change in each firmware version, you should have a configuration file in the syntax that is compatible with the firmware. Remember to read the release notes. Sometimes a downgrade between firmware versions that preserves the configuration is not possible, such as when the OS changed from 32-bit to 64-bit. In that situation, the only way to downgrade is to format the disk, then reinstall. After you've confirmed that the downgrade is possible, verify everything again, then start the downgrade. After the downgrade completes, restore a configuration backup that is compatible with that version. Why should you keep emergency firmware and physical access? Earlier firmware versions do not know how to convert later configurations. Also, when upgrading through a path that is not supported by the configuration translation scripts, you might lose all settings except basic access settings, such as administrator accounts and network interface IP addresses. Another rare but possible scenario is that the firmware could be corrupted when you are uploading it. For all of those reasons, you should always have local console access during an upgrade. However, in practice, if you read the release notes and have a reliable connection to the GUI or CLI, it should not be necessary. Congratulations, you have completed this lesson. Now you will review the objectives that you covered in the lesson. This slide shows the objectives covered in this lesson. By mastering the objectives covered in this lesson, you learned how and where FortiGate fits into your network and how to perform basic FortiGate administration.